Hi everyone, this is Srikanth, Assistant Professor of EEE Department. In this session, I'm going to cover the definitions on electrical machines and semiconductor diode. Give some applications of shunt and DC series motor. Here, shunt motor is going to work in a constant speed. So, wherever we require constant speed motors, in those applications, we can use the DC shunt motor, whereas DC series motors are going to provide us the high starting torque because the current field current is proportional to the armature current, so it will provide high starting torque. So these DC series motors can be used where we require the high starting torques. So shunt motors driving constant speed lathes, centrifugal pumps, machine tools, blowers and fans, reciprocating pumps. Whereas series motors are going to be used in electric locomotives, rapid transit systems, trolley cars, cranes and hose conveyors. Mention the applications of DC generator. DC generator is nothing but it is a machine which converts the mechanical energy into electrical energy. So we are getting the output from the generator as electrical energy, where we are going to use the DC electrical energy. Those are the applications of DC generators, that is general lighting and use it to charge battery because they can be made to give constant output voltage. Whatever the batteries are there, we are going to give the supply in order to charge the battery. That DC output from the generator will be given to the batteries, and they are also used giving the excitation to alternators because alternator is a doubly excited machine. Along with the mechanical input, we also need to give the electrical input. That electrical input is also in the form of DC supply. In order to develop the field flux in the field winding, we need to give some DC supply to the alternator. So the DC supply can be taken from the DC generator and also used for small power supply units. Give some applications of compound DC shunt motor. In compound DC shunt motor, we are going to have nearly constant speed and high starting torques because of the both series and shunt windings. So in the compound motors can be used in elevators, air compressors, rolling mills, heavy planners. Okay, wherever we are going to have both the combination of torque and constant speed, in those applications we are going to use the compound motor. Write the principle of DC motor. Here, if a current carrying conductor placed inside a magnetic field, then the conductor will experience a force in the direction of mutually perpendicular to both the direction of field and armature winding, or we can also call it as it is a current carrying conductor. Here, if a current carrying conductor is placed in a magnetic field and it is perpendicular and magnetic field in perpendicularly, then the conductor experiences a force in the direction mutually perpendicular to both the directions of field and the current carrying conductor. What is the main purpose of commutator and brushes? The commutator converts the alternating EMF into unidirectional, or direct EMF, unidirectional or direct EMF. That is nothing but alternating voltage which we are going to develop in the DC generator, that will be converted into DC voltage by using the commutator. And brushes are used to collect the current from the commutator. Brushes are the intermediate part between the generator and the output terminals, which are going to collect the current from the commutator and give it to the load terminals. What is meant by armature reaction in alternators? Here, armature reaction is nothing but the interaction between the main flux and the armature flux is called the armature reaction. The interaction between flux set up by the current carrying armature and the main flux is defined as the armature reaction. The major problems with the armature reaction is main flux is going to be distorted. Because of main flux is distorted, the EMF induced will be changes. So that is the major problem which we are going to get with this armature reaction. Describe the classification of DC generators. DC generators basically classified based on how the field winding is connected. So here the field can be connected in two ways. One is separately we are going to give supply to the field winding, and another one is by connecting the field winding to the armature, and the armature itself is going to serve the current for the field winding in different formats. That is called self excited generator. So basically the generators are classified into two types. One is separately excited DC generator, that is nothing but the field winding of this particular generator is excited separately. And the next one is self excited DC generator. These can be again classified as again self excited DC generators based on how it is connected, based on how the field winding is connected. These are classified into three types: series generator, shunt generator, and compound generator. And again in the compound generator we are having long shunt and short shunt. Mention the characteristics of DC shunt motor. Whenever we consider the motor is nothing but it is a machine which converts the electrical energy into mechanical energy. So our output characteristics also in the mechanical terms. So the characteristics of DC shunt motor, the three important shunt characteristics are: first one is the torque versus armature current. How much amount of torque is developed corresponding to the armature current which we have given. That is our first characteristics. And the second one is speed versus armature current characteristics. How the speed is going to change corresponding to the armature current. And the last one is speed versus torque characteristics. Define DC generator and state its principle. DC generator is an electrical generator which takes the mechanical energy and converts into electrical energy for operating any machines. And the energy changing is based on the principle of electromagnetic induction. Here, according to Faraday's laws of electromagnetic induction, whenever a conductor cuts a magnetic field, the EMF will be induced in the conductor, and that EMF is dynamically induced EMF. When an external load is connected to the conductor, This induced EMF will make a current flow in the load. Differentiate between Zener breakdown and avalanche breakdown. Zener breakdown occurs in a reverse bias junction which gives a constant output voltage. Zener breakdown is going to occur in a reverse bias junction where it gives a constant output voltage, where avalanche breakdown does not provide a constant output voltage. This constant voltage from a Zener diode can be used as a reference voltage for many regulators. This constant voltage can be used as a reference voltage for many of the regulators. What is an ideal diode? An ideal diode is nothing but ideal diode which offers zero resistance when it is forward bias. That is nothing but ideal diode is going to act like a short circuit during the forward bias and infinite resistance when it is a reverse bias. Infinite resistance is nothing but it is a open circuit when it is a reverse bias. So the ideal diode will be like a short circuit in the forward bias and open circuit in the reverse bias. List some of the applications of Zener diode. Zener diode is going to have a wide commercial and industrial applications. Some of their common applications are, the first one is voltage regulators, because the voltage across the Zener diode is going to be maintained constant. So these Zener diodes can be used in the voltage regulators. And the second one is we can also use these Zener diode as peak clippers or voltage limiters. Next, what is depletion layer? At the instant the two materials are joined, the electrons and holes in the region of the junction will combine. At the instant once the P and N layers are going to be connected, immediately the electrons and holes in the junction will combine, resulting in a lack of carriers in the region near the junction, which will result a lack of carriers in the region near the junction. This region of uncovered positive and negative ions is called depletion layer. The region of uncovered positive and negative ions is called the depletion region. Define motor efficiency and generator efficiency. Motor efficiency is nothing but it is the output power by input power. Here the motor efficiency is nothing but motor is going to have the output as the mechanical power, input as the electrical power. So the motor efficiency is defined as the ratio of mechanical power output to the electrical power input. And generator efficiency, it is the ratio generator is going to generates the electrical energy from the mechanical input. So the generator efficiency is defined as the ratio of electrical power output to mechanical power input. The next one is peak inverse voltage. Peak inverse voltage is defined as the maximum reverse voltage that a diode can be subjected to operate in a reverse region, so that the diode does not get damaged due to this reverse voltage. So this is the maximum reverse voltage that a diode can withstand. That is nothing but peak inverse voltage. The diode can be subjected to operate in the reverse region so that the diode does not get damaged due to this reverse voltage. The next one is state the condition for forward bias and reverse bias of PN junction diode. Forward bias condition is established by applying a positive potential to p-type material and negative potential to n-type material, so that the holes in the p-type material will move towards the junction and the conduction will takes place. Whereas reverse bias condition is established by applying a positive potential to the n-type material and the negative potential to the p-type material. So here we are going to have the electrons in the n-type are attracted by the positive, so that there is no junction breakdown will occur because of the electrons and holes. So this will create a reverse bias. There is no conduction will takes place in the reverse bias. In the forward bias, the conduction will takes place. In the reverse bias, the conduction will not takes place. In the forward bias, diode will acts like a conductor. In the reverse bias, diode will acts like a insulator. Define semiconductor. A semiconductor is a material that has electrical conductivity between that of a conductor and an insulator. The conductivity of the semiconductor can be controlled and modified by various factors such as temperature, impurities, or an applied voltage, unlike conductors which have high conductivity and insulators. Which is these semiconductors are going to have the electrical conductivity between the conductor and insulators, and these conductivity of semiconductors can be controlled with different factors by using temperature and by adding impurities or by an applied voltage, unlike conductors which have high conductivity and the insulators which have low conductivity. But semiconductors will be falling between these two extremes. Define conductor. A conductor is a material that allows the flow of electric current. In conductors, electric charges such as electrons can move freely within the material in response to an applied electric field, where metals are most common examples of good conductors. Generally, the conductor is going to have a less resistance, which is going to allow the electric current. So, all the metals are the examples of good conductors as they have a high density of free electrons that can carry electric charge easily. Define insulator. An insulator is a material that does not conduct electric current easily. Insulator is a material which is having high resistance, so no current will flow through the insulator. In insulators, the electrons are tightly bound to the atoms and they do not move freely in response to an applied electric field. As a result, insulators have high electrical resistance, meaning they resist the flow of electric current. So, insulators are going to have a high electrical resistance which is going to resist the flow of electric current. State Faraday's law of electromagnetism. Faraday's law of electromagnetism are the fundamental principles in the understanding of electromagnetic induction, which is the process of generating an EMF across a conductor in response to changes in magnetic flux. This phenomenon is the basis for the operation of generators and transformers in electrical system. That means whenever a current carrying conductors moves inside a magnetic field, so that an EMF will be induced. That is nothing but Faraday's laws of electromagnetic induction, and that EMF is directly proportional to the rate of change of flux linkages. State Lenz law. Here, Lenz law is a fundamental principle in electromagnetism named after the German physicist Heinrich Lenz. It describes the direction of the induced EMF, electromotive force, and resulting current in a conductor that is exposed to a changing magnetic field. Lenz law is a consequence of conservation of energy. Lenz law is a consequence of conservation of energy. Lenz law can be stated as follows. The direction of induced current in a conductor will always opposes the change in magnetic flux that is produced. So Lenz law is nothing but effect should oppose the cause. Here the effect is EMF induced and the cause is magnetic flux that produced. So always the induced current in a conductor is going to oppose the magnetic flux that produced in it. State Fleming's right hand rule. Fleming's right hand rule for generators. Thumb indicates point it in the direction of the motion, that is the magnetic field or conductor moving. Index finger, it points in the direction of magnetic field, north to south. Middle finger, it points in the direction of generated current. The sequence of thumb, index and middle finger represents the sequence of motion, magnetic field and generated current. Whereas Fleming's right hand rule for motors, the thumb indicates point on the motion, conductor or current carrying wire. Index finger point it on in the direction of magnetic field, north to south. Middle finger points in the direction of force, thrust or motion. Again, the sequence of thumb, index finger and middle finger represents the sequence of motion, magnetic field and force. State corkscrew rule. Here, imagine turning a right-handed corkscrew in the direction of electric current. The direction in which corkscrew advances represents the direction of magnetic field lines around the current carrying conductor. If the current carrying conductor current is flowing in the direction of screw, how we are going to fit? So how we are fitting in that particular direction, the flux is going to be develops. And in this rule, the direction of corkscrew rotation corresponds to the direction of electric current. And the axis of corkscrew represents the direction of the magnetic field. Describe energy bands. Here, the valence band, the highest energy band that is fully occupied by electrons at absolute zero temperature. Electrons in this band are bound to atoms and continue to the stability of the solid. The conduction band, the next higher energy band, which is empty at absolute zero electrons in this band. Electrons in this band are free to move and can participate in the electrical conduction. So in the conduction band, the electrons are free to move, whereas in valence band, electrons in this band are bound to the atoms and contribute to the stability of the solid. Describe band gap. The energy gap is the energy difference between the valence band and the conduction band. It represents that the energy required for an electron to move from the valence band to the conduction band. Here the materials are classified based on their band gaps. Here conductors are going to have a very small or no band gap, which is allowing the electrons to move freely between the bands. Semiconductors have a moderate band gap, allowing some electrons to move into the conduction band at higher temperatures or with external influences or by applying some voltage. And insulators have large band gap requiring significant energy to move electrons from the valence band to the conduction band. Describe energy levels and electron movement. In a crystalline solid, energy levels of individual atoms combine to form bands. The number of electrons in a band is equal to the number of atoms contributing to that band, where electrons can move between the energy bands by gaining or losing energy, such as through the absorption or emission of photons. Define Fermi level. Here, Fermi level, which is represents the highest energy level in the valence band at absolute zero, and it is a measure of probability of finding an electron at a particular energy level and influences the electrical conductivity of a material. Define diode. A diode is a semiconductor device that allows current to flow in one direction while restricting it from flowing in the opposite direction. Current is going to flow only in one particular direction, and in the other direction the current will not flow. That's why diode is also called as unidirectional element. In other words, a diode acts as an electrical check valve or a one-way gate for electric current. Diodes are fundamental components in electronic circuits and are widely used for rectification and signal modulation, signal demodulation, voltage regulation, and other applications. Define rectifier. Rectifier is an electrical device that converts alternating current into direct current. The primary purpose of rectifier is to rectify or convert the direction of the current flow from positive negative oscillation to a unidirectional flow. AC supply is converted into a DC supply, and this process is essential for many electronic devices and power supply applications where a steady and unidirectional current is required. Describe full wave rectifier. Full wave rectifier is going to allows current flow in both halves of the AC cycle, and it utilizes either two diodes in a configuration called a bridge rectifier or four diodes in a full wave center tapped rectifier, and it provides a more efficient conversion of AC to DC compared to the half wave rectifier. In this, we have covered the definitions on electrical machines and semiconductor diodes. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.